three basic things, okay? You work with three basic things. Well, I'll say four. Yeah, four. Let's say four basic things, right? Okay, so issue number one, units, right? Issue number one, units. So first thing you want to remember, these are helpful hints, right? Helpful hints. Okay. So when doing these kind of problems, first thing, every single time you write down a number, write down in units. Write down units for all numbers, right? For all numbers. Okay. All right. Second thing. So units. What are units? Units are what? Like liters. Well, grams. Meters. Well, yeah. What's another simple one? Seconds, for example, or whatever, right? But in chemistry, we're doing moles, right?
Yeah, moles.
Those are units, right? Okay. Then what happens is, don't get confused, but when you're dealing with proportions of those units, right? You'll see things like, with concentration, you'll see like molar mass would be what? Grams per mole, right?
Yeah.
Remember that grams per mole equals molarity, right? No, it equals molar mass, right? Moles per liter. This is molar mass. Moles per liter is molarity. I'll put a capital in here. Molarity, right? What's another one? Derived per kilogram. Yeah. So molality would be what? Moles per kilogram, right? Moles per kilogram. Now, another issue, don't confuse scaling for units, right? All fundamental units or derived units have scaling to them, right? What do I mean by scaling? In other words, grams is a fundamental unit, right? If I scale it, it could be kilograms, it could be milligrams, it could be et cetera, right? So don't let that throw you off. So if I say moles per milliliter, right? That's the same thing as moles per 1 times 10 to the negative 3 liters, isn't it? So make sure you have that straight first as well, right? Or you can have millimoles per liter. Like millimoles per liter, right? That's the same thing as 1 times 10 to the negative 3 moles per liter, see? Don't get that confused. Right? So those are several issues. So always pay attention to see, ask yourself, is it a fundamental unit or is it a derived unit? Derived unit is typically when you start dividing the units by themselves or mixing them up, right? Okay. Then you have your scaling. Okay. Make sure, is this unit scaled? Ask yourself that question. Is it scaled? Well, if it is scaled, is a question asking me for it scaled or unscaled? So if you're giving kilograms and they ask for grams, then you need to rescale it back, right? So that's what I believe this gentleman is kind of like saying he needs to practice with. That's when you know when to do what. It's getting this squared away in your head. Okay, this would be unscaled, right? Take the kilograms off. That's without scaling. If I apply this to scaling up or down, very, very large or very, very small, that's your what do you call it? King Henry died by drinking chocolate milk. That's what I mean by scaling. Did I apply? Did the problem employ King Henry died by drinking chocolate milk? Did it do that? Yes or no? If it did, then you need to either recalibrate the numbers and scale it back to what they're asking for, or the opposite of that, right?
Yeah.
Because they give you kilograms, but they ask you for kilograms, they gave you grams, and you need to scale it up, right?
So you need to find what kilograms that is because they give you grams, right?
Right. Then you got to move the decimal place, right?
Okay. Yeah.
So these are the different things that we're asking you to.
It's like it's basic math, but it's just it gets confusing. You got to move.
Well, it's got to sync up in your head. Yeah, it's got to sync up in your head. See, it's got to all become synchronized as one thing, not several different things, right? Now, the key to doing that is don't follow the numbers. Follow the units. Now, if you don't write the units down, you can't follow them. Does that make sense? Right? If you're writing down a bunch of numbers without the units, you're going to miss these kind of details. You're going to miss that every time. So if you're reading the problem and you have a 10, you say, it's going to be 24 divided by 112, and my answer is, whatever that is, right? Then that's when you make these kind of errors. Because if you didn't write down your units, then you don't know whether it's scaled or not. Now, the way to avoid getting lost like that is when you read the problem, go ahead and write down what you're given. So let's go over that. So write down all units, all numbers, right? Your first step. Step 2. Write down what you're given with all units, right? Write down given. All the given. So like when you read the problem, you'll say, you can do like a T-chart or something. What am I given? Then on the other side, say, what are they asking me for? Right? And when you write down your given, it could be, they might say, for example, you have, 5 moles of whatever substance in whatever milliliter cylinder. Find out how many grams you have to add, right? So you're going to write all that down. Now you say, you write down 5 milliliters equals volume. You write down, you write down my molar mass. Molar mass might be something like, 16 point whatever grams per mole, right? You write all that down, and then you say, what are they asking you for? So they might be asking for the mass, right? All right, what's the mass? In what? Kilograms or grams or whatever, see? You go in and write that down, and then you start working the problem, and now you have something to refer back to. So you got to organize it in your own way, right? Not everybody can just be chaotic like me, right? Like I'm pretty chaotic, right? It's all over the place. Because I'm following the units, though. Yeah.
Majority of the time in molality problems and molarity problems, you're going to have to incorporate the molar mass into the problem. In
The periodic table.
Periodic table.
Yeah. If you're getting stuck, refer to your periodic table and check. Oh, okay. Did they give me molar mass? Yes or no? Right? What else? Okay. Huh? Oh, on the periodic table? That's haterade, man. That's haterade. Okay, so all right. So in your book, right, in chapter 4, they go into types of chemical reactions, right? So they give you 3 types. This is in 4.4. They give you 3 types of reactions. You've got precipitation reactions, you got acid-base reactions, and you have oxidation reduction reactions, right? And has anyone ever seen that thing on Beautiful Chemistry? You ever seen that? You ever seen that Beautiful Chemistry? Okay. So let me give you. guess we could check that out, I guess. Beautiful Chemistry, you never seen that? Yeah, Beautiful Chemistry is a, I think it's a Chinese or Japanese group. They start analyzing a bunch of these reactions. And they put fairly high power microscopes. That's what they're doing business. And so they did an experiment with reactions, and they filmed these reactions, and then they put music to it. It's pretty cool. Let's see if I can pull it up. Let's see. And then I'll put your homework on the board while that's going on. Be free to leave. It's beautifulchemistry.net. Paper clips. Let me see. This right here. Yeah. So when you go to the laboratory, you have a better feel of what's going on because they show it at the atomic scale. And next time we'll talk about these different reactions. And actually, I believe it's Tuesday and Thursday. Yeah, I may have to move the class back about 30 minutes. I think. Yeah.
We're moving class back 30 minutes.
Yeah.
Why?
County, man. Atlanta, man.
It's got that lab.
Oh, what's protocol do you start? I mean,
Oh, yeah? Okay, well, don't worry about it.
Do you take 285?
No.
I mean, like,
Do
which
we actually
protocol
just-
do you stay in?
No, you taking the wrong way. You taking 85, 75?
Yeah.
That's the wrong way. You need to take 285 and then hop on I-20.
Oh, 166.
On 166.
I'll try that.
Try Tuesday before
Yo,
you
like,
take
just hop
the
on
class.
20. That's your best bet. Honestly.
Yeah, that's
Like, there's no traffic.
I don't believe you.
I mean, I'll take
They
20.
got jokes. I'll be out there till like. They got jokes, man. You're going away, man. You do it.
That was funny. No, bro, you say 20 rarely has traffic.
Right. I'll try that out.
I take 20 every day, so. I get here before you.
Yeah, this is so like yeah, there you go. Yeah, so they give you the different. See, that's zinc plus copper sulfate. Gives you copper plus zinc sulfate, right? That's was lead nitrate, zinc nitrate. So you got crystallization, precipitation, acid-base reaction. Now those trees growing. See, that's precipitation there. See that? Silver nitrate plus sodium chloride. We do that experiment here sometimes. So you get silver chloride plus sodium nitrate. So you got aqueous solution is the black, white stuff is the precipitate. Similar here.
So it's heavy.
Right, uh-huh. So what happens, you get ion exchange, and then if it gets real heavy, it falls out of the aqueous solution, or the aqueous solvent, rather. So silver nitrate's a typical compound to use to get that ion exchange going. Get it copper
What is he at?
hydroxide, sulfur nitrate. You can go back there and do it yourself if you want. Calcium chloride, sodium, cobalt chloride plus silicon oxide. A lot of crystallization reactions, when you go to the laboratory, you'll like actually mix the compounds together, and then you'll actually filter out the crystals with a filter, hot water filtration. And then sometimes you gotta let it sit. Do the next class, let the crystals grow some more. And you can measure the weight. So it's basically law of conservation of energy and matter. The mass before the reaction, the mass after the reaction should be the same, even though it transforms from aqueous to solid or precipitate. That's it. All right, so, read the lights for me.
In this animation, we'll see the remarkable way our DNA is tightly packed up so that 6 feet of this
Alright,
long
so
molecule fits into the
homework.
microscopic nucleus of every cell.
We're gonna look at,
The process starts when DNA is wrapped around special protein molecules called histones. The combined loop of DNA and protein is called a nucleosome.
yeah, 33.
Next, the nucleosomes are packaged into a thread. The end result is a fiber known as chromatin. This fiber is then looped and coiled yet again.
There you go. So actually moves along at a good pace.
Next time.
Where you go after that?
Leading